La diffusion vient de démarrer. Tous les participants sont en mode écoute seul.
Good morning, everyone. I am, excuse me. I am George Carbonell, responsible for the southern region of Europe, and we are also online with François Sabel, who will do part of this presentation. Today's webinar is basically linked to high availability and performance with Redis Enterprise clustering technology. And what we'll do today is we'll introduce you to Redis Labs and also go into further details in terms of what Redis technology brings to you and how the architecture allows you to have both high performance and combine it with high availability. So let's get started. Who we are, basically Redis is the leading in-memory database platform in the world. It supports both operational analytics and hybrid use cases. And the main aspect around Redis is basically high performance, and it's recognized by a multitude of use cases, benchmarks, and so forth as the leading, the fastest database on the market. Redis Labs is the company behind Redis Enterprise. It's the home of open source Redis, and we are a company designed to optimize Redis technology, platform, products, and services.
George, I'm not sure if it comes from my connection, but I don't see your screen.
Thank you for saying so. Up. Perfect. I think that...
now I can. Yes, I can.
Perfect. Sorry about that. I had forgotten to press the button. So yes, to get back to what I was saying, who we are basically Redis, the leading in-memory database platform, and Redis Labs is the home of Redis. We have over 7,000 enterprise customers who have adopted the full version of Redis, both on cloud instances and on-premise. Now, if I stated a few seconds ago that Redis is the fastest database on the market, it's also the #1 database on the cloud. It's #1 in AWS, #1 in Node.js. It's also known as the fastest growing database by DB Engines. And we have also the immense honor of being the #1 database on Docker. Other benchmarks and rankings and analysts put us as the most loved database by developers. That's stated notably by Stack Overflow. If you look at the DB Engines database popularity score, DB Engines, for those who don't know, is a ranking of all the databases around. So you have both SQL databases and NoSQL databases. As you could see here, you have Oracle, MySQL, the Postgre, the user suspects, and Redis is the third NoSQL database. But more importantly, it is the fastest growing database, and this has been the case since 2013. And as I indicated earlier, for all of those of you who are interested in Docker and containers, Redis is the #1 database on Docker, even faster than, well, more important than Mongo or MySQL instances. Now, what are the key components, the key differentiators of Redis? As I indicated, performance. and we'll get into that in a minute. The simplicity of Redis, the fact that Redis is not only a database geared towards performance, but it has the capacity of using different data structures. And thirdly, the fact that you are able to extend the core of Redis through Redis modules. Now, if we talk about performance, Redis has the highest throughput with the lowest latency in various use cases. Here, what you can see on the left side of your screen is basically the highest throughput with high volume of writes. And as you can see, Redis far surpasses its the competitors on that screen. But what is extremely important as well is how do we achieve this performance and what kind of resources you need to put in place to achieve these results, this performance. And if you look at the graph on the right, you'll see that the cost associated with Redis is extremely low in terms of infrastructure and so forth, because you don't need that many servers to obtain and to achieve your SLAs. If you need to deliver 1 million writes per second, well, the cost estimated by one of the benchmarks that we could easily find on the web, or that we could point you towards shows that the cost would be $14,000 roughly, and that is because in terms of delivering 1 million writes per second, you only need probably maybe 2 servers. In this case, it was 2 servers that you would need to achieve that. And in the case of Couchbase and Cassandra and others, you need to put a lot more servers to achieve those performances. Other benchmarks relating notably to Hadoop, HDFS, Tachyon, and Spark shows that Redis is 100 times faster than HDFS, 45 times faster than Spark. In this case, you could see that the execution time, the average execution time is in seconds, and smaller is better. Now, why use Redis in an operational context? Well, if the new norm today, the new standard is trying to achieve 100 milliseconds return response time, and this has to be something that you try to achieve under any load. Well, if you do that, you separate it into 2 segments, 50 milliseconds each. That means that your database has to achieve 1 millisecond response time. Redis is practically the only database able to do that regardless of the load. The de facto 100 millisecond response time requirement is achieved thanks to Redis in this for this kind of usage. If you look at more analytical OLAP kinds of use cases, what you're able to achieve with Redis is that where your queries were taking days, thanks to Redis and its RAM in-memory technology, your query will now take minutes. If it took hours, it will take seconds. That is the kind of results differences that you can achieve with Redis. Now, if we look at the simplicity of using Redis, Redis can be used for different kinds of data structures. You could use strings, you could use it for bitmaps, you could use it for bit fields, you could use it for hashes, lists, sets, sorted sets, geospatial indexes, hyperlog, and also streams. So you're able to use Redis in for different use cases. You're able to use different data structures directly at the core of Redis. Redis is able to understand these different data sets, and you're able to push different functionalities directly at the core level of Redis. You're able to turn complex functionality into single commands. You're able to process data at the database level directly instead of doing it at the application level. And you're able to use standardized or even customized commands to achieve this. The result is that you have a cleaner and faster execution time. One of the key aspects of all those who use Redis and know Redis well is the fact that you can extend Redis very easily. Instead of having a one-shot development, you're able to use pre-existing Redis modules. And if a pre-existing Redis module does not meet your requirements, you're able to create or have a third party create for you a Redis module. The advantage of that is that you're able to use Redis API to seamlessly support your use case, your data structure. You're able to push directly at the core level of Redis specialized functionalities, and you're able to enjoy Redis's super high performance, its scalability and high availability, all the while using it for a specific case that you could reuse that Redis module for other use cases that are similar. And all of this can be in a supported environment because any Redis module that are tested and certified by Redis are supported. And thanks to these elements, you're able to turn Redis into a multi-model database. Hence, you're able to use Redis for different use cases, different solutions, etc. So we find that Redis is used in e-commerce, in IoT, in social apps, fraud detection, metering, anything relating to real-time needs. And if we look at in another way, the first thing that comes to mind when we talk about Redis, when people who know Redis for the last number of years, is caching. Why? That was the first thing that was brought to mind because of Redis's architecture, the way it works, the fact that it's the way it's designed, the fact that it is an in-memory database. Well, the thought was, okay, let's put that power to use immediately. Let's speed up our existing applications, our existing databases, and combine it and put in Redis as a cache. What we found over the last few years is that companies have been using it for a lot of other needs. Anything, as I stated, that needs real time, so high-speed transactions, analytics, and notably real-time analytics, but also messaging, search. What a lot of people don't know is that the Redis search is the fastest search module system in the world. So that allows you to have some nice functionalities in terms of search and achieve that in real-time scenarios. But you also have fast data ingests, time series, geospatial indexing, and so forth. Redis is versatile. You could use it for transactional, operational, and analytics. If we look at the transactional use cases, you could use it for authorization, authentication, price management, bids, messaging, user management, session management. You could use it in terms of analytics for counting, leaderboards, rankings, recommendation engine. We have a good number of use cases around those. Time series analysis, session analysis, secondary index, not even to speak of machine learning scenarios as well. And then operational, whenever you need real-time attribution search, order history, etc., etc. The list is quite long. Now, if we go into more detail around the subject of today, what is the Redis Enterprise advantage? True high availability. So if we look at this this wheel, we have the different scenarios. If we start off with high availability, durability, disaster recovery, you're able to have high availability across data centers, across zones, racks, geographies. You're able to basically prevent any kind of physical or other kinds of disaster, and really split it out in terms of those kinds of elements, determine a specific kind of zone for each Redis shard, for example. The other item is that with Redis Enterprise, a lot of key enterprise level functionalities are automated, and you could either manually set it up, you could manually change it, but you could also have it so that it's automated. And the advantage of that is that you could have instant auto failure in just a few seconds. With Redis, you're able to have a recovery from a disaster in just 5 seconds with absolutely no data loss. You have the persistent data layer. You also have seamless scaling. What we call seamless scaling is the fact that you're able to add new instances, new shards, split them, etc., etc., and all of that without downtime. Obviously, you have backups, automated backups that could be put in place, and the disaster recovery element is extremely important. We'll go into more details into those items in a few minutes. The other nearly revolutionary but extremely cutting-edge technology is the fact that Redis can be active-active, and it could be active-active over different geographies. That means you're able to have reads and writes in multiple geographic regions with the same data set. You take advantage of local latencies, all the while having a global, worldwide availability. That is a huge plus for companies who have implementations that are across different regions and want to avail of the advantages of having high-speed local connections, all the while having something consolidated. The other aspect is that in order to do this, you have to have a mechanism that deals with conflict resolution. That is built in with Redis, and it is built in both for simple and complex data types. And it could be it's something that could be very easily managed, administrated. The other key aspect as well is the security. There's multiple authentication mechanisms. The administration has role-based authorizations. You can encrypt the data in transit and at rest, and you could track and log all of the different admin actions for what we call here forensics, but basically to follow up and identify what's been done and when and by whom and so forth. We're able to achieve all of that, and we're able to achieve true high availability, all the while having the highest performance on the market. We're able to have that because of our technology, because of the way the architecture works, our clustering technology, the fact that we are also able to have linear scaling of performance, and Francois, my colleague, will go into more details in a minute on that. And all of this with seamless scaling, auto sharding, rebalancing, with high performance pipeline execution. That is a key aspect, an important aspect that we'll go into as well. The fact that you are able to manage all of that, have schedule, and also have cluster support for every client. As I indicated earlier, you have a built-in search with rapid-fire real-time search and indexing, and you could do this with text, numeric, geospatial, and you could also do it for secondary indexing of data from any other DBMS. One interesting aspect is that although Redis is an in-memory database, you're not limited to the memory. We have clients who use Redis for hundreds of terabytes and use Redis to its fullest extent. In other words, they use both high availability, they obtain a high performance, and they're able to do that obviously with RAM, but also thanks to extension into flash memory. The advantage of flash memory is that the costs are lower by 80%, but also in some cases it can be easier to extend and implement. The other aspect is that you have fewer servers that you need to put in place to achieve different memory sizes. You can have benefit from multi-tenancy to maximize the resource utilization. And when you use flash memory with Redis, you do not at all lose out on performance. And we can explain to you how we achieve this. The last part of this, practically the last part of this wheel, is the fact that you can use Redis through command line. You could use Redis through the API, and you have a user interface whereby all you have to do is tick a little box, and up you could activate replication. You tick another box, you could activate a new shards, etc., etc. So it makes it a lot easier for administrators to administrate Redis or to implement Redis, deploy Redis very easily, and to monitor it. So the monitoring, the alerting, the reporting of Redis is all simplified and helped through those three methods. The API, which you could use to pilot direct Redis, but also the user interface and the command line. You have a complete control of the different processes. Redis is fully automated, and you could manage the cluster management and the way it works. You also have built-in optimization and balancing of workloads, which is extremely helpful in those cases. And obviously, you have 24/7 expertise and support at your fingertips when you're using all of these functionalities with Redis Enterprise. One of the great advantages of Redis is the fact that you could use Redis modules. These modules allow you to extend the use cases for which you use Redis. It allows you to push it directly at the core level using the API, and you could use native JSON data, for example, graph storage, query processing, machine learning, neural net, multi-shard coordination, etc., etc. It's basically, thanks to Redis modules, you could extend infinitely, practically, the use cases that you could use Redis for. If we were to summarize a little bit the benefits of Redis, you could summarize it in both the fact that you have effortless scaling, always on availability, and you are able to lower your cost. Effortless scaling, what does that mean? It's linked to the automation, the fact that you can seamlessly manage both clustering, you have linear scaling, auto resharding, auto scaling, and all of that through an interface that is extremely easy to use. You can have Redis can be ACID compliant. You can adjust the level of compliancy to your needs, to meet your needs. And obviously, we support all of the Redis Enterprise modules, the ones that have been certified or validated by Redis. And if you create your own, well, get in touch with us and we could organize its certification. The core of this of the architecture is the always-on availability. The fact that you have instant failure recovery with no data lost, and all the while benefiting from stable, predictable performance, and all of this with a distribution on an active basis if you need it. The lowering of cost, one of the key aspects is that you can use flash memory as a RAM extension. And most importantly, with Redis, you need to put in place less resources, less servers to achieve your SLAs, to meet your SLAs. And that means you have lower overhead, lower management needs. The support is 24/7 and is there for you at the fingertips or at the end of a phone. Earlier, I was talking about disaster recovery. With you have basically here 5 different vendors of which you have of databases of which you have Redis. As you can see on this graph, Redis is the only one that allows you to do no data loss. All the other ones have data loss to a different extent, and is the only one to do this in a matter of seconds, 5 seconds to be precise. All of the other ones are above 180 seconds, which basically means they're all in minutes. So if you want quick, instantaneous data recovery with no data loss, Redis is the database that you need. If you want to achieve true high availability that meets different requirements, process failure, node failure, multi-node failure, network splits, zone or rack failures, region, cloud failures, Redis is the database for you. We provide in-memory replication, multi-zone replication, auto failure, always-on functionality, which allows you to be 100% always on, and also multi-regional replication. Now, what I'm going to do now is pass the microphone over to François Serbel, one of our solutions architects, who will present to you the architecture of Redis.
Hi everyone. Well, I'm François Serbel. I am a solution architect at Redis Labs. So I take care about all the technical stuff such as presentations, proof of concept, trainings, demonstrations, and things like that. So, I would like to say that Redis is a multi-tenant database. So it means that we are not limited in the number of databases that you can create in a Redis cluster. It means that you can have a single Redis cluster for your enterprise, and then for each new application, you can create a new database in Redis. That's not an issue. And when your cluster is full, you can extend your cluster and create new databases. So you can have as many applications and as many databases as you want. And if you are in a B2B model, it means that you can have, each time you have a new customer coming, you can create a new database for this customer. And each database will be completely isolated from all the other databases in terms of memory, in terms of files, in terms of processes. So on the next slide, you can see that we have several data types. What I mean is that most of the NoSQL databases are specialized. Well, you have families, you have key value databases, you have documents databases, you have graph databases, but most of the time they implement only one or, well, at least few data types. For example, in a document database, you can store usually JSON documents or XML documents, but nothing else. In Redis, it's quite different because it is a key value in-memory data store, but it stores not key values, but key data structures. So the data structure can be as simple as a simple value, but can also be quite complex. And we have about 10 data structures out of the box, as George said. But you can also extend Redis with other data structures or other features using modules. So it means that if you have a specific data structure that you want to store and to persist, you can use Redis for that and tell Redis, how is your data structure? What do you want to do with your data structure? And then he will take care of that. On the next slide, we can see that Redis is not only a database, a data store. Of course, you can give data to Redis, and Redis will store your data, and you can retrieve it. But Redis is also a communication layer. You can use Redis to communicate between your applications. Why? Because, well, today applications are split into several parts. For example, you can have an application layer, which is the front end for your customer. Let's say an e-commerce application. So the user can see the items and buy the items. And you have another application on the same database which manage the stocks. So it means that in Redis, you can store all your product catalog with your items into Redis. The first application will display the items to the customer, so he can open an item on his screen, and he can see that these are still, well, let's say 2 or 3 of them in the stock. But in the meantime, you have other customers who buy this item. So the stock is decreasing. And all these applications can communicate together. So when a customer buys an item, then of course it decreases the stock, the number of items available in the stock, but it also can notify all the other applications that made a change. The customer was on the page of the item was available, but while he is still on the page, he can see that now the item is no longer available because you don't have the item anymore in the stocks. So you can use this communication layer for a lot of things, to synchronize your applications, to do real-time data processing, and well, you can do whatever you want. On the next slide, I can tell you that we are, as most of the other NoSQL databases, we are able to have Redis cluster in one data center and another Redis in another data center, and why not a third one, a fourth one, as many as you want, and we can synchronize them. What is interesting, and it is a key feature of Redis, I don't know if it is available in any other database. Redis is able to federate all the changes and to consolidate them to have a consistent view on your data. What I mean is that if I take my example of stocks, if you have an e-commerce solution with one warehouse somewhere, and so you have one stock, And you have several front ends, and you have several clusters. Each front end is connected to one cluster. And when a customer in the States buy an item, if a customer is in Europe and buys the same item, at the end, your stock should be decreased by 2. And Redis is able to do that. It can guarantee that you can have a multi-master and active-active architecture so that your data will be consistent and will be what you expect. It is based on a mathematical model which is called CRDT, and you are sure that you will have the right value at the end. Well, on the next slide, I can tell you that we also support transactions and logs, which is not so common in the NoSQL databases. You can implement transactions, and not only at the key level, but between keys. So it means that you can update several keys, several documents in a single transaction. You can also implement optimistic and pessimistic locks in Redis. An optimistic lock is when the conflict is quite rare. So basically your application bets that there will be no conflict and tries to update an information in the database. If there is a conflict, it will manage the conflict after it occurred. It is optimistic lock. And the pessimist lock is when you think that there will be a conflict most of the time. So you can lock your records, then you are sure that you will be the only one to change the record, and you change it, and then you unlock it. We have both the options in Redis, and we have several ways to implement transactions. On the next slide, excuse me, something which is very important. And when you use Redis, there is a huge community around Redis. It means that when you want to implement a specific use case and you hit an issue, you don't know how to implement it, you can query Google or any other search engine, and you will see that a lot of people already had the same use case and already implemented it. So you will have an amazing knowledge base on internet because we have a community. And so this community is using a lot of different languages to connect to Redis. And we have now about 40 different languages supported. Some of them are pure development languages, such as Java, Python, Node.js, C, C++, and so on. But some of them are also more specialized, such as Scala, and you can use them for data analyst, for example. And we also have more specific or more rare languages, such as Rust, or other one that I never heard about before. So you can find a lot of information, and you will find a lot of support from the community. Then on the next slide, something also very important in the enterprise context is that you will also find a lot of resources knowing Redis. It means that in enterprise, when you want to use Redis, you need to have developers, you need to have ops, and sometimes with other solutions which are, well, I would say more closed or less spread, then it's hard to find valuable resources to use the solutions. With Redis, it is very easy because there are a lot of people knowing Redis and able to develop using Redis. On the next slide, I will talk about the different data types. Well, as I told you, Redis is not only a key value store, but a key data structure. The data structure can be as simple as a simple string, but it can also be a set of unique values. So it means that you can have a key, and in front of this key, you will have a set of unique values. And if you want, of course, you can get the whole set, or you can send the whole set to Redis, but the set can be huge. So it can be long to travel through the network. And it also means that you will have to deal with concurrent access if you choose to get the whole set updated and send the whole set back to Redis. Instead of that, for a set, for example, you can also ask Redis to know if an item belongs to the set, or you can ask Redis to add a new item to the set, or to remove an item from the set, and so on. You also have sorted sets. Sorted sets are exactly the same, but each item has a score associated with him, and the set is sorted by the score. So it means that on top of all what the standard set gives you, you have more features. You can ask Redis, I want to have the first 10 elements, 10 items of my set, or I want to have the last 10 items, or I want to have all the items with a score between A and B. And if your scores are timestamps or priority, you can implement very easily. It is one way to implement time series. Then you have also another powerful data structure, which is a list. A list is a sorted list of items. They are not unique. So with a list, you can add a new item at the beginning or at the end of the list. You can add remove an item from the beginning or from the end of your list. But you also have operations to remove, to get the first item of your list and to push it into another list. So it means that you can implement very easily some kind of job queues with one list with all your pending tasks, and workers the task from this list and processing them. And you are sure that each task will be only processed by one worker. And if your list becomes more and more loaded, and if you don't have enough workers to empty your list, then you can start a new worker beside all the others, and it will work with all the others. You have also bit fields, which are basically a powerful way of counting. You can, for example, use bit fields to know how many unique visitors you had on a specific web page. And then you can combine bit fields together to know how many unique visitors on this web page, but only male, married, with children, and so on. And it is bitewise operations. It is quite fast and very, very powerful. And then, if you don't find what you want in our data structures, you can add new data structures to Redis. As an example, I told about JSON previously. We don't have JSON as a native data structure, but JSON is available as a module. So it is an extension. It is an example of extension. And as soon as you load the module into Redis, it becomes a native data structure because the modules are loaded by the core of Redis. You can implement new data structures, but also new features such as machine learning, neural network, Bloom filters, search engine, whatever you want. Then on the next slide, yes, here it comes. Redis community has all these data structures and features, but well, everything is here, to implement a business need. But as soon as you want to go to production in enterprise, you will need something else. You will need some features to deploy, to provision, to administrate, to monitor your database. And Redis community doesn't have enough features for that. So Redis Labs implemented a layer on top of Redis community. All the Redis community data structures and commands are available, but on top of that, you have new features to manage your cluster and your database. On the next slide, we can see that the main components are the proxy, the cluster manager, and the REST API. And then on the next slide, you will find the detail. The proxy is here to deal with all the incoming connections from your application. Basically, the proxy knows all the cluster complexity with data sharding, with data replication, with all the nodes, and so on. And it exposes, it publishes to your application a simple API as if it were a single Redis instance. So it means that your application doesn't need to know that there is a cluster behind. Your application connects to the proxy as if it were a single Redis instance. And then the proxy has all the knowledge to optimize all the connections and to find your data. The cluster manager is in charge of managing all the nodes, new nodes, to remove a node, all your databases, to create a database, to extend the database, to reshard the database, to rebalance the database. It deals also with all the failures and things like that. Then you have the REST API, which is a better fit with the cluster manager. And this REST API enables you to first monitor your cluster, so you can get the health of your cluster, and also to interact with your cluster manager. So it means that you can have a script or a monitoring tool, as we made, which monitors Redis cluster, and when your cluster becomes overloaded, then it automatically starts a new Redis instance somewhere, a new Redis node somewhere. It includes with the REST API a new node in the cluster, and then it asks the cluster manager to rebalance the data. So you can achieve auto-scaling with the REST API. On top of the REST API, you have command line tools, and you also have a web user interface for your DBA. On the next slide, I explain you how to have a cluster. Basically, a Redis cluster is made of an odd number of nodes because of a quorum. So, and then each of the nodes are absolutely the same, with the same binaries, with the same processes, with the same services. So you don't have any specific node which would be a single point of failure. All the nodes are absolutely the same. On the next slide, you can see that as I told you, we can achieve easily multi-tenancy, and you can deploy as many applications as you want, as long as you have hardware resources in terms of CPU, RAM, disk, network. You can create new databases. And then on the next slide, I will tell you how to achieve scalability. Well, basically, a database can be hosted in a single Redis instance. A single Redis instance is a process which is a mono-threaded process. I mean, you have only one thread for the data access path. It is a design choice because it is more efficient to have all your queries executed one after the other than to have all your queries executed in parallel, but with all the overhead of concurrency checks, and logs and things like that. So it is mono-threaded. It uses only one core, but one is able to achieve about approximately 25,000 operations per second. So when your database usage grows, you will need more operations per second. Then you can ask the cluster manager to split your database in 2 equal parts to shard your database. And then you will have 2 Redis instances that will serve your database. It means that you will have 2 cores that you will be able to achieve approximately 50,000 operations per second. And then you can shard and reshard as many times as you want, as long as you have CPU cores. On the next slide, I explain you how to scale when you used all the available hardware resources. Once you used all the cores, then you can add a new node to your cluster. When you add a new node to your cluster, you add new CPU cores, you add more RAM, you add network bandwidth, you add disk bandwidth. And then once you added a new node, which is at the beginning empty, you can ask the cluster manager to rebalance your data across your cluster. So your node will begin to be used, but you still have available resources so that you can continue to reshard your database or to create new databases using the extra RAM available. On the next slide, I explain yes, once again. Next, please. Yes, so how do we achieve high availability? Well, it's very easy. Each Redis instance can host data. And if you want, you can check the box, I want high availability. And basically, each Redis instance hosting your data will have a replica somewhere else in the cluster. And it is a huge difference with the community edition. In the community edition, you can create your replica, and then the replica can be on the same node as the master. But with the Enterprise edition, everything is managed for you. So basically, when you create a replica first, it will never be on the same node as the master data. So it means that you can survive to a node failure. But not only, there is more. You can have several nodes using the same shared hardware resources that can fail. For example, a switch, a power supply unit, air conditioning, or something like that. And if you have the node 2 and node 3 using a shared power supply unit, for example, that can fail, all your data that are in the node 2 will not have the replica on node 3. They cannot, because they would share a resource that can fail. So the replica of your data which are on node 2 will be on node 1 in this case. On the next slide, I explain you how we manage a failure. As an example, the first scenario is if one of your instances fails. Your applications are connected to a proxy, and then all your data are in one of the instances, in the master instance. But this master instance fails. The cluster manager will immediately promote the slave instance, the replica, as a new master, and the proxy hides all the cluster complexity to your application. So basically, your application will not lose the connection to the proxy because the proxy is still up and running, but the proxy will forward your query not to the first instance, but to the other one, to the slave instance which was promoted master. Then the cluster manager is smart, and you asked him to have high availability. It had high availability. It used it to maintain your data availability, but now it is not anymore in a highly available state. So it will create a new slave somewhere in the cluster to return to a high availability state. All these three steps are fully automated. And the last one, which is to go back to the original situation, can be automated too. Basically, by default, it is not, because it is highly dependent on your architecture, infrastructure, business needs, and so on. On the next slide, I explain you how to achieve high availability when you have a proxy failure. In that case, of course, your applications will lose their network connection. But as soon as they lose their connection, basically, a simple application will just retry to reopen the connection. And in the meanwhile, the cluster manager changed the IP address of the endpoint so that your application was connected to database.cluster.enterprise.com, which resolved in the IP address of the first node. So it lost a connection to database.cluster.enterprise.com, but the IP address changed, and now the application is connected to the second node, to an up and running proxy. And this proxy will forward your queries to the right instance. Then, as previously, the cluster manager will also restart a new proxy to return to an highly available state. All these steps are always fully automated. And then, in the fourth step, it is automated. You can automate it. It is not automated by default because it is dependent on your architecture, infrastructure, and business needs. But you can automate it, as we did in one of our offerings. On the next slide, I try to explain you how to manage a whole node failure, but it is very easy to understand. It is nothing else but the two previous scenarios combined. So you have a proxy switch and you have a shard switch. And then the cluster manager will restart all the missing resources to return to an highly available state. On the next slide, I will just make a small stop here. At Redis Labs, we offer we have Redis Pack. Redis Pack is the software, and we can provide Redis Pack as a box. So you download it, you install it, you administrate it, you use it. But you can install it on in Docker, in a container, in a virtual machine, on-premise, in your data center, in a public cloud, Amazon, Google, Azure, IBM SoftLayer, and so on, in a private cloud somewhere in these providers, as well, everywhere you want. And you install it, you manage it, you use it. But we also provide Redis as a service, and it can be installed and managed by us and by our scripts on-premise or in a public cloud or in a private cloud. And when you use Redis as a service, you just have to create a database and size it, and then everything behind the scene is made by Redis Labs and our scripts. Everything is automated. On the next slide, I explain why do we have a proxy. Well, it's quite easy to understand. If you have a database which is sharded in two parts, with or without replication, in the community edition, your application needs to be connected to both of the shards, because half of your data is in one shard, half of your data is in the other shard. and your application needs to be aware of the cluster topology to know where to get which data. On the next slide, I explain you that the proxy, which is in the middle, has all this knowledge. The proxy is smart. The proxy knows where your data is, in which instance, and where are the instances, in which node, and so on. So that your application can open only one single connection to the proxy, and then the proxy will automatically fetch your data where it is, and will do that completely transparently. It is very easy for your application to use a proxy. On the shard side, you have less incoming connections to manage. On the next slide, I explain that the proxy optimizes the connections to the shards. Basically, it is able to pipeline and multi your queries to low latency. Then on the next slide, I think it is 2 slides ahead. Yes, another one. Well, we are a key data structure data store. We are in memory, but we can do persistency. We have the ability to persist your data per operation or per on a time-based fashion. You can choose to have all your operations written to disk when they occur. You can choose to have the persistency at every second or more than seconds. It can be 6 hours, 12 hours, 24 hours as you want. For that, we have 2 technical mechanisms, which are snapshots and happen-only files. Snapshots are, as they say, a snapshot of all the memory down to the disk. Happen-only files are redo logs. So basically, Redis, when you stop a cluster and restart it, can reload the last snapshot and re-execute all the operations that occurred since this snapshot. Then, on 2 slides ahead, we also have replication, a cluster, a database to database replication. When you create a database, you can ask it to replicate all the data from another database, but not only one. You can have many databases to one. It can be in several clusters. It can be in several data centers. So it means that you can federate all your data from the US data center, European data center, Asian data center into one single database to have a consolidated view on your worldwide activity. It can be bidirectional, and when it is bidirectional, it can automatically resolve conflict so that you don't have any inconsistent value in your database. I gave you an example with the stocks at the beginning of this presentation. You can use this feature for disaster recovery, for geo-proximity of your data. You can use it also if you have, for example, an operational database which needs to have a low latency, and you have analysts who wants to execute complex queries. You don't want that the analyst complex queries to have an impact on your operational database. So you can replicate all the operational database into an analyst database, which is differently sized, and then they can do whatever they want. On the next slide, I can explain you also that the Enterprise Edition has another very interesting feature. Redis is an in-memory key data structure store, but in memory, one more slide, please. In memory means that you might have sooner or later more data than you have RAM. So Redis is able to use disk, fast disk for sure, but is able to use disk to extend the memory. It will keep all the metadata in memory. So it will be able to answer very quickly, I have the data or I don't have the data. And if it has the data in memory, it will return the data. If Redis doesn't have the data in memory, the data was ejected to disk, then it will fetch the data from the disk and return it to the application. It doesn't all the use cases, but all the use cases that use hot and cold values are might be interested by this feature, because when you have hot and cold value, you have a fitting use case, and in that case, you can achieve nearly the same performances as Redis purely in memory, with about 50% of your data in memory only, and 50% of your data on the disk. Next slide, please. Yes, you can choose also with the persistency to have weak persistency or strong persistency on the disk, because when your application sends data to the master shard, the master shard immediately acknowledges the reception of the data, and then it will send the data to the replica asynchronously. And the replica will acknowledge to the master shard. Then the replica will write it to disk, and the operating system will acknowledge that it received the data. But the data is still not on the disk because you still have to flush the buffers, and later it will be flushed. But anyway, for your application, it was very, very fast. It is useful for user sessions, for example. On the next slide, I have a diagram which shows the opposite option, and you have also all the intermediate options. But here I have the opposite option, a strong consistency. Your application sends the data to the master shard and then asks the master shard to wait before sending the acknowledgement. So the master shard will not acknowledge the data, but will send the data to the slave. The slave is configured to write the operations in an append-only file, but with fsync at every operation. So the slave sends the data to the operating system and triggers an fsync. So the operating system will acknowledge the data only when it will be actually on the disk. And then the slave will acknowledge the reception of the data to the master, and the master will acknowledge to the application. In that case, it is another option. It is the opposite option, the strong consistency option, which is interesting, for example, for invoices. So I think that I covered most of the features of Redis. We have a lot of other features, such as stored procedures, modules, well, and we can discuss that if you want. You can send us your questions, and we can schedule a call, or you can answer by email, or you can schedule a meeting if you want, to show you all these other options, all these other features of Redis. George, maybe you want to add something.
Yes, thank you. Thank you, Francois. The main thing here to come out with is basically, if you're interested in Redis, if you want to find out more information, if you want to link up to one of our demo sessions, we would be glad to provide that. The demo session could be quite quick. In less than an hour, you could see exactly in a concrete manner everything that Francois explained. Just send me a quick email, and we'll be able to sign you up for one of these sessions, so you could go into it. It's perfect. These sessions are 100% free, obviously, and they don't engage you on anything. It just allows you to get more information. And if you are interested possibly in a trial version, or you want any help regarding an evaluation or technical questions, same thing. Send me a little email, and I'll try my best to answer your questions. We wish you all good projects and a good day, and we hopefully will be in touch very soon. Have a good day.
Have a good day. Bye bye.